Hey makers, welcome back to Hub360 Embedded Sphere, your go-to spot for embedded projects and affordable electronics. Today we are building a digital clock on a P10 LED panel using Arduino Uno and a DS1307 RTC Module. This clock shows hour and minute in bright 5 times 7 digits, a blinking column, and when the column blinks off, it shows AM or PM in the corner depending on the time. All parts are available at hub360.com.ng. Affordable, tested and shipped nationwide. Let's get started. Now here are the things to take note of. The DS1307 RTC keeps time even when powered off. The Arduino fetches the time and drives the P10 LED panel. A blinking column separates hours and minutes. When the column is off, you see AM or PM depending on your time. The components used are one Arduino Uno, a P10 LED display panel 32 by 16 pixels, a DS1307 RTC module with CR2032 backup battery, the jumper wires, a 5 voltage power supply, 2 amp recommended for the P10 panel. I'm using a buck converter to convert my 12 voltage source to 5 voltage. All these components are available at hub360.com.ng. Now let's make our connections. We are connecting the P10 display to Arduino Uno. So first, we start by connecting the red data pin on the P10 display to the pin 11 Arduino Uno. Next, we connect the A pin on the P10 display to the pin 6 on the Arduino Uno. We are connecting it to pin 6 on the Arduino Uno. Then next, we are connecting the B pin on the P10 display to the pin 7 on the Arduino Uno. Then next, we are connecting the clock pin on the P10 display to pin 13 on the Arduino Uno. And next, we are connecting the latch pin on the P10 display to the pin 8 on the Arduino Uno. Then we are connecting the output enable on the P10 display to the pin 9 on the Arduino Uno. Then we are connecting the R data pin on the P10 display to pin 11 on the Arduino Uno. Now let's power it up. We connect our VCC on the P10 display to 5 voltage of external power supply. I'm using a buck converter. Where is it? Using a buck converter to step down the voltage from 12 voltage to 5. And ground to external power ground of external power supply. So now we connect our RTC module to the Arduino Uno. So first, I'm going to connect the SDA pin to A4 on Arduino Uno. Then the SCL pin to A5 on the Arduino Uno. We connect the VCC of the RTC to 5 voltage on the Arduino Uno board. So here's our VCC, connecting it to 5 voltage on the Arduino Uno. Ground 5 voltage. And then now connecting the ground of the RTC module to the ground on the Arduino Uno. And there you have it. Important tip: connect the ground of the Arduino Uno, P10 and RTC module together. Now let's go ahead and program our Arduino. First, we include the libraries needed to drive the P10 and communicate with the RTC. The next, we set up display and RTC in this section. Then we do our time conversion. We convert our time. So in this section, we read the time from RTC and convert 24-hour format to 12-hour format with AM, PM, depending on your time. And then we go to the blinking section. In this section, the column blinks each second, and when it's off, the AM and PM is displayed depending on the time. Now, before we go and upload, we need to set the RTC time. So in the code, in this line here, we uncomment it, then we upload the sketch. So once we upload it, we comment it back again and re-upload, so that the time doesn't reset every time. Insert the CR2032 battery in your RTC. Upload the sketch with RTC adjust enabled to set the clock. Re-upload with it disabled. Power the P10 panel with 5 voltage, at least 2 amp. Watch as time shows up in hour and minutes with blinking column. Notice AM or PM appears when column is off. And that's it, your very own P10 LED digital clock with AM, PM and RTC backup. Big bright digits, blinking column seconds, auto AM, PM toggle, RTC timekeeping even when off. If you're enjoying this build, hit like and subscribe to Hub360 Embedded Sphere. All components are at hub360.com.ng, tested and shipped across Nigeria. Until next time, keep building, keep innovating.